Evaluate logarithms with negative integer solutions. Super, super exciting. All right, so to evaluate logarithms, we got a couple steps. So first, we're going to rewrite it as an exponential function. Then we will solve it. And because logarithms have certain things that must be true, like the base must be positive, the argument must be positive, we must check for restrictions. So just remember, when we have the log of an argument with a base, both A must be positive and B must be positive. They both must be greater than 0. Okay, so remember the basic idea of logarithms. If b to the y equals x, then log of x base b equals y. Okay, so the base of the exponent is the same as the base of the logarithm. Then I like, in my non-mathematical way to explain it, say, okay, y is the exponent. It's touching the base in the exponential. That means it can't touch the base in the log, right? So you can see like the y and the x switch places. That's the way that I remember things. I also like to say base b to the y equals x. I like to do these big swoopy things. I am a visual learner. If you are also a visual learner, then write things down and do swoopy things. Do whatever you need to help it make sense to you. Okay, let's do a couple. Let's evaluate. The y equals the log of 1/16 base 2. We're starting with a hard one right off the bat. Okay, so we always start with our base, and then we say 2 to the y equals, swoop it around, 1/16. And I know you're thinking, it's okay. Just relax. Let's think through what we know. Well, we know 2 to the 0 is 1 because anything to the 0 power is 1. And 2 to the first is 2. Well, that's going the wrong direction. I need to get smaller. So if I go 2 to the negative first, remember, negative exponents, flip it. So this becomes 1 over 2 to the first, which is 1/2. That's not big enough. So I'm going to go 2 to the negative 2. So that's 1 over 2 squared, which is 1/4. We're getting closer. 2 to the negative third is 1 over 2 to the third, which is 1/8. We're getting closer. 2 to the negative 4 is 1 over 2 to the 4, which is 1/16. So that means our y value is -4. Now, when we go check up here, remember, the only restrictions is for the base and the argument. Those are both positive, so we're good. And our answer is y equals -4. Now let's evaluate. Log of x base 3 is -3. Again, we start with the base. So 3 raised to the -3 equals x. Okay, so let's think through playing with negative exponents. So remember, negative exponents mean we flip it. We take the reciprocal and the exponent becomes positive. So this is the same as 1 over 3 cubed. So x equals 1 over 27. And again, that would mean we'd have log of 1/27 base 3 equals -3. Our only care is the base and the argument. Those are both positive, so we are good. 1/27 works. And last but not least, the log of 1/81 base x equals -4. So we start with base x, raise it to the -4th power, and we get 1/81. Okay, so now you're thinking, whew. All right, let's think through this logically. I know that a negative exponent flips this. So that would mean that x to the 4th is 81, right? If I get rid of my negative exponent, right, that flips it. So now I've got to think, what raised to the 4th power is 81? Well, I know it's not 1 because 1 to the 4th is 1. 2 to the 4th is 2 times 2 times 2 times 2. That's 16. 3 to the 4th is 3 times 3 times 3 times 3. That's 81. So that means my x is 3. So 3 to the -4th is 1 over 81. Yes. Okay, so let's go up here and let's check it out. That means the log of 1 over 81 base 3 equals -4. Base is positive, argument is positive, so yes, my answer is x equals 3. And that's it.